topic of Chapter 3 is the 95% confidence interval. And in this first video, I'm just going to introduce that concept. So to begin with, let's think about why do we do statistics? Well, there's many reasons, but one reason may be to draw inferences about populations. In this course, we're going to focus on two different processes for drawing inferences about population. And the first one we've already seen is null hypothesis statistical testing. So, as a review, the null hypothesis that we were thinking of testing was that cattle were not having any impact on plant cover. So our null hypothesis was that mu, which was the difference in plant cover between the grazed and the ungrazed plots, was going to be equal to 0. So we went out there and we took our sample of size n equals 9. We determined that y bar was equal to 1.0, that s was equal to 1.2. We calculated our particular value of t, which is y bar minus mu over s divided by the square root of n. We got 2.5. And we got a corresponding p-value of 0.020, which said that if in fact the null hypothesis was correct, if the cattle weren't have any effect on plant cover, then the probability of getting a difference as great or greater than that we observed, which is 1.0, would be very low. And as a consequence, what we assumed was that the null hypothesis was incorrect, and in fact, the cattle were reducing the amount of plant cover. So that's one way in which we can draw inferences about populations. And what this Chapter 3 is going to focus on is another way of drawing inferences about populations, and that's through the construction of 95% confidence intervals. So 95% confidence intervals. And so the way this chapter is going to proceed is as follows. We're going to think about 4 different scenarios. And we can think of those 4 different scenarios of different combinations as to whether or not the population standard deviation is known or unknown. Now, I think in your notes, I make reference to whether or not the variance is known or unknown, but obviously if you know the variance, you know the standard deviation, so that whether or not I speak in terms of variance being known or standard deviation being known isn't going to have any impact. So we got that, and then we got a question of what parameters we're interested in. Are we interested in drawing inferences, getting a 95% confidence interval on a single population mean, or the difference between 2 population means? So once we set up this grid, we see our 4 different scenarios. Drawing inferences about a single population mean when sigma is known. Drawing inferences or a 95% confidence interval on the difference between the 2 population means when sigma is known. Drawing a 95% confidence interval on a single mean when sigma is unknown. And then finally, a 95% confidence interval on the difference between 2 means when sigma is unknown. And from a practical point of view, the one you're really going to be interested in, most likely going to be dealing with in your own research, is this one. So if you think about your own research, at a minimum, you're quite likely to have at least 2 treatments. You're likely perhaps to have a treatment and a control. So you're interested in the difference between treatment and control. Or even, let's say, if you got 3 treatments. Let's say you've got these 3 fertilizers, N, P, and K, nitrogen, phosphorus, potassium. You might be interested in, okay, what's the difference between nitrogen and potassium? Excuse me, nitrogen and phosphorus, nitrogen and potassium, phosphorus and potassium. So you'd still be interested in the difference between 2 means. So the way this series of lectures is going to proceed in this chapter is that we're going to start here, and then we're going to do here, and then we're going to do here, and then we're finally going to wind up here. And the reason for that is, although this is where the money is, this is where the action is, in order to really understand it, we have to go through this process to get there. So, we're talking about 95% confidence intervals. That's the subject of this chapter. So, what the heck is a 95% confidence interval? I just want to give a quick overview. Let's assume that the population of interest is the IQ of students that are present in Old Scona High School, kind of an elite high school, in the fall of 2020. Down here, we've got a number line. And we could reasonably expect that if we had the records of all the students, we could actually calculate the average IQ of all those students, or not really calculate it, we'd have it present in the data. And so that's represented here as the true population mean that exists along some number line. So what we're going to do is we're going to take a sample from those records and we're going to calculate two numbers. And we can think of those two numbers as being the lower limit. So lower limit and an upper limit. So that represents a single 95% confidence interval that we're going to calculate. Now, if we were to repeat this on another day, we get a lower limit there and an upper limit here. If we do it on another day, lower limit there, somebody else did it, they might get an upper limit there. And so if you consider the set of all possible lower and upper limits, we can define those as lower limit and upper limit. Those two numbers, we can think of those as being a random variable. So we've seen lots of random variables before. I mean, the two that we focused on were y, which is a set of all possible single individuals, and y bar, which was the set of all possible sample means. Now what we're dealing with is random variable, and it's kind of an odd duck in that instead of being a single letter, we're actually dealing with a range. But it still fits the criterion of a random variable because it arises through a mapping process. It takes some observations, and we're going to go over the mechanics of how that's done, and translates the results of an experiment into a pair of numbers. And also you can recognize that this thing here is the set of all possible 95% confidence intervals that could be constructed by this process. And the thing to keep in the back of one's mind as we go through this is to focus on the process. And the reason I say that, I wish I knew how to spell that, but that doesn't look too bad. The reason I say focus on the process is that when we think about what a 95% confidence interval is, it is a process such that we think about a random variable, the set of all possible intervals that we construct. So there's one possible, there's another. A random variable is the set of all possible intervals we can construct. We're going to go through a process such that 95% of those intervals would cover the mean. And that's what I've attempted to draw in this figure here. So here's our number line. There actually is a true population mean. If we had the record for every student that was enrolled, we would know what that value is. But we could take a sample of those records and get an interval there. We get another sample, an interval there. Another sample, interval there. We could repeat that an infinite number of times. And because the process that we're going through, 95% of those intervals would cover the mean. And you see most of these intervals cover the mean, but then we've got this fellow here. 5% of the time, 5% of the possible values of our random variable, that pair of numbers, would fail to cover the true mean. So we'll stop there with that brief introduction of a 95% confidence interval.